My name is Peter from TÜV Austria. We are also joined today by Peppi Airike from Accountability Standards team. It's great to have her with us. So today we will talk about AA1000 standards in the circular economy and recycled materials. This course is developed in the context of TÜV Austria's collaboration with accountability, applying AA1000 principles to circular economy claims. Many sustainability claims fail not because of bad intentions, but because of unclear wording and weak evidence. In this session, we will connect three things: chain of custody models, AA1000 assurance thinking, and common certification schemes. The goal is simple: make recycling and PCR claims clear, credible, and not misleading. So let's start. First, I will share today's roadmap and what you can take away. So here is today's topics. We have 4 parts. First, we start with the big picture, what circular economy means and why recycled materials matter. Second, we go into the technical foundation, recycled materials and traceability models. For example, segregation, controlled blending, mass balance, and book and claim. Third, we look at evidence through an AA1000 lens. In simple words, what proof is strong, what proof is weak, and what controls are needed. Finally, we connect this to the real world, standards and certification scheme, and the common issues we see in real projects. The goal is to make recycled content claims assurance ready, with the right traceability, governance, and impact story. So let's start with part 1, what circular economy means and why recycled materials matter. This slide sets the context. For many years, our economy was linear: take, make, use, and dispose. Now we are moving to a circular economy. We try to keep materials in use and reduce waste. This is not only about the environment, it is also about how value is created and protected in supply chains. In a circular model, the goal is simple: use less virgin resources, use products longer, and bring materials back through reuse and recycling. Design is a key lever. If packaging or products are designed well, durable, repairable, and recyclable, the recycling works. If design is poor, the material value is lost and the claims become risky. And this is where AA1000 comes in. It helps us connect claims, evidence, and stakeholder trust. So if circular economy needs materials to stay in use, the next question is, how do we prove it, especially for recycled content? Now, let's talk about plastic and recycled content first. Plastics are everywhere in the value chain: packaging, electronics, cars, textiles, and many daily products. Plastics are also unique for one reason: end of life is complicated. Collection, sorting, and recycling can be leaky. Some materials is lost, and some can end up as waste or pollution. That creates system risk, policy presence, and also reputation risk for brands. So why does recycled plastic matter? First, it can replace virgin fossil-based feedstock. Second, it can reduce carbon intensity, but this depends on the system boundary and real data. Third, It helps circularity, but only if we have good design and good traceability. In short, recycled content is a particular level, but it only works when the claim is clear and the evidence is strong. So the next question is, what is driving recycled content adoption? Policy, market demand, or both? This slide answers a common question: why recycled content is growing so fast, and what that means for accountability. There are four main drivers. First is regulation. In Europe, we see rules like packaging requirements and also national measures such as plastic tax. This makes recycled content targets more and more mandatory. And, and there there can be financial penalties if companies cannot move through compliance. Second is market demand. Many brands have 2025 or 2030 commitments. Retailers also ask suppliers to prove certified PCR. This creates high demand and sometimes a price premium, but only when the claim is credible. Third is climate pressure. Companies focus more on Scope 3. Recycled materials are often seen as one lever to reduce upstream emissions, so people look more closely at methodology and data quality. Fourth is consumer transparency. Rules on green claims are getting stricter, so generic words like eco-friendly are risky. Third-party verification becomes important to prevent greenwashing and protect trust. The takeaway is simple. Recycled content becomes a business and compliance topic. Proof becomes as important as the claim. Before we talk about traceability models, we need a basic distinction: pre-consumer versus post-consumer recycled material. This is important because it affects typical quality, risk, and also what evidence we need. Pre-consumer means waste from manufacturing that never reached the end user, like scrap of cards or rejected parts. One key point: it usually excludes simple in-process reuse without modification. If you just reuse the same material inside the same process, that is more like process efficiency, not recycling. This is quite important. Post-consumer means materials that already reached the intended user and is no longer used for its original purpose. Compared with pre-consumer, it often has higher contamination and higher polymer mix risks, labels, residues, and adhesives. So the assurance focus is different. For pre-consumer, we need to prove the origin and make sure it is not just internal regrade. For post-consumer, we usually need stronger evidence on collection and sorting, communication control, contamination control, and also yield and loss. And one reminder, PCR is about feedstock origin, not about the recycling method. Mechanical versus chemical is a different topic. So, PIR and PCR tells us the origin of the feedstock. Next, let's separate origin from process. Mechanical versus chemical recycling. This slide is about the recycling process, mechanical versus chemical. A quick reminder, PIR, PCR is origin. Mechanical chemical is how we reprocess the material. We should not mix these two concepts. Mechanical recycling is mainly physical steps: sorting, washing, shredding, and melting. The polymer chemistry stays the same. It is mature and scalable. And in many cases, it has lower energy consumption and carbon emission. But it is sensitive to contamination and makes the polymers, and the quality can degrade after repeated cycles. So downcycling can happen. For assurance, we focus on input controls, process controls, output specs, and evidence of yield and reject rates. Chemical recycling breaks polymer down to monomers or base chemicals. It can handle more complex and or contaminated streams, and in some cases can produce virgin quality outputs, but it is usually higher cost and the environmental benefit can be debated. For assurance, the hot spot is often mass balance, system boundaries, allocation rules, and very clear claims wording. So first be clear where the materials comes from and how it is recycled. Then make sure your claim is supported by documents, data, and controls. Now we understand the origin and the recycling process. The next step is how do we track it through the supply chain so the claim is auditable. This is the role of chain of custody. Now I would like to introduce chain of custody or COC. COC makes sustainability claims auditable because it connects two things, the physical flow of materials and the information or claim flow. Physical flow moves forward from collector to recycler to converter to the brand. At each CC means a change of custody. The information must follow and be reconciled. So what do auditors test? Mainly three areas. First, controls. For example, segregation rules or mixing rules. Second, reconciliation, input and output balance, and how losses are handled. Third, claim wording. What is promised versus what can be evidenced. If these three parts are strong, the claim is much more credible. If one is weak, the claim becomes risky. This is the case slide for traceability. There are different chain of custody models, and the model choice determines what you can credibly claim. On this chart, from left to right, the physical presence becomes lower. On the left, you have high physical certainty. On the right, you move more into bookkeeping or credits. Model 1, identity preserved. One single source. You keep the identity of the material. This is used when provenance is critical. Model 2, segregated. Certified and non-certified are kept separate, but you can mix certified sources together. This is often used for 100% recycled content claims. Model 3, controlled blending. Physical mixing is allowed, but with clear rules and quantitative control. This is often used to verify a specific recycled content percentage. Model 4, mass balance. Physical mixing happens, and the recycled attribute is allocated using accounting rules. It is common in large-scale systems, including some chemical recycling value chains. Model 5, book and claim. The physical product is decoupled from the claim. You buy certificates or credits, but you must be very careful with wording. One simple takeaway. As you move to the right, you need stronger accounting controls and clear claim wording because physical evidence becomes weaker. Now you have the full map. Next, we will take a closer look at the two models with the highest physical certainty, identity preserved and segregated. Now, let's zoom in on the two models without mixing, identity preserved and segregated. Identity preserved or IP means single source and the identity is maintained. The strongest point is provenance. You can see exactly where the material comes from. In audits, we focus on identity controls and documentation continuity, so the identity story never breaks. Segregated means certified material is kept separate from non-certified throughout the chain. Here you can mix certified sources together, but you cannot mix with non-certified. The strength is strong physical presence, often used for 100% certified material claims. In audits, we focus on storage and labeling, segregation controls, and batch records. A simple way to remember. Identity preserved is one source, same identity. Segregated is many certified sources, but always separated with non-certified. Next, we move to the models with mixing or load, controlled blending, and mass balance. And this is where wording becomes critical. Now we move to the models with mixing, controlled blending, and mass balance. People often confuse them, but the logic is different. Controlled blending means the mixing is planned and controlled like a recipe. You can verify a percentage because there is a clear mixing recipe and quantitative records. It is common in mechanical recycling or production tuning. For assurance, we check recipe control, input-output reconciliation, and loss factors. Many balance is different. Mass balance is different. Certified and non-certified materials are physically mixed, and the recycled attribute is allocated by accounting rules. This is common where segregation is impractical. For example, in large-scale chemical systems, for assurance, the key is the allocation method, conversion losses, and especially how the claim is communicated. The simplest takeaway is the sentence at the bottom. Controlled blending answers what percentage is physically in the product. Mass balance answers what attribute is allocated to the output. This is why wording is so important for mass balance. This slide is about mass balance, its value, the controversy, and how to keep claim integrity. First, why mass balance used? Because it enables transition at scale. Many systems cannot build parallel lines for certified and non-certified materials. Mass balance also works better for complex or contaminated streams, and it can support investment ramp up. But why is criticized? Because allocation can decouple the physical flow from what people think the claim means. If wording is unclear, consumers may misunderstand, and companies face greenwashing concerns. Transparency depends on clear rules, clear wording, and independent verification. So here is simple wording controls. To see recycled content attributed via mass balance when applicable. Don't imply physical presence if it is attributed. And do disclose the certification scheme and allocation approach in B2B documents. Finally, the mini decision logic is, if you can physically separate, use IP or segregate it. If mixing is planned with a measurable recipe, use controlled blending. If mixing is unavoidable, mass balance can be used, but only with wording, with strong accounting and useful wording. So mass balance can be acceptable, but only when rules are strict and wording is honest. Now the question is, who checks this, and how do we conclude a claim is trustworthy? That's where AA1000 comes in, as the governance layer. So far, we focused on the technical layer. We learned that a chain of custody links physical flow and claim flow. We also learned that the model choice defines the claim type, physical content versus attributed content. And the main risks are reconciliation gaps and misleading wording. Now we move to the next layer, governance. This is where AA1000 adds value. AA1000 gives us principles and process to test three things: materiality, evidence quality, and claim integrity. In simple words, it helps us answer one structured question: is this claim trustworthy? So think of it like this. ISO 22095 tells us how to track and document. AA1000 helps us judge where the way we manage, communicate, and evidence the claim is credible for stakeholders. We said AA1000 is a governance layer. Now, let's make that relationship more clear. This slide summarizes the relationship in one sentence. Chain of custody tells us what we claim. AA1000 helps us judge whether the claim is trustworthy. In practice, AA1000 works like an assurance methodology. We start from the evidence, documents, data, and controls. Then we apply AA1000 test to check if the disclosure is credible and evidence is useful for stakeholders. And finally, we reach an assurance conclusion. In AA1000 Assurance version 3 standards, the assurance provider evaluates adherence to four principles. The focus is integrity, transparency, and sustainability information that people can actually rely on to make decisions. Next, we will introduce the four principles one by one because they are the core of the AA1000 lens. These are the four principles in AA1000 assurance standards. They are the core checks behind the AA1000 trustworthiness conclusion. Inclusivity means stakeholder voice. Who is affected and how were they engaged? Materiality means focus. What topics and claims really matter for decision users, like brands, regulators, and customers? Responsiveness means action and transparency. What control and actions respond to the issues, and how is performance tracked? Impact means real-world outcomes. What changed in reality, not just the activities or inputs. We will apply these principles to circular economy claims. For example, recycled contents, chain of custody models, and evidence. Next, we will go deeper, first on inclusivity and materiality, then on responsiveness and impact. Now we go deeper into two principles, inclusivity and materiality. A simple way to remember, inclusivity is about people. Materiality is about what matters for decisions. Inclusivity is a stakeholder reality check. For a recycled content claims, who should we engage? Upstream actors like collectors, aggregators, and recyclers. Also brands and retailers because they are claim users. And we should not forget affected communities, workers, and consumers. What do we evidence? We show stakeholder mapping, who is affected and how. And we show engagement channels like interviews, audits, complaints, and supplier feedback. Materiality is about topics that matters to decisions. Ask, what would change decisions if claim was wrong? For recycled content, what must be read includes the PCR proportion and the boundary, standard time period, and the set. The chain of custody model, physical versus attributed, and what the claim does not mean. Key quality and risk factors, contamination or chemical safety, and the relevance of the end outcome, like recyclability or closed-loop feasibility, including key limitations. This key message is stakeholder input help us refine the claim scope, the risks, and the disclosures, so the final claim is both relevant and trustworthy. Once we know who matters and what matters, the next step is what actions and controls respond to the risks and what real outcomes are achieved. What brings us that brings us to responsiveness and impact. Now we look at the other two principles, responsiveness and impact. A simple way to remember, responsiveness is performance over time. Impact is the real-world outcome. Responsiveness is about discipline, targets, actions, results, and transparent reporting. For example, a company says 30% PCR in all primary packaging by 2025. Then we expect them to report progress with a clear method and boundary, and explain any deviations. Most importantly, claims must be accurate and substantiated, not only promise. Impact goes beyond the content numbers. PCR percentage is useful, but stakeholders also ask, what changed in the real world? For example, how much waste was diverted from landfill or the ocean? How much water was saved in washing? Or what life cycle GHG reduction was achieved based on a clear method and assumption. The takeaway is AA1000 is not only about having a number, it is about responsible action, transparency, progress, and evidence of outcomes. Now, let's see how AA1000 assurance is done in practice. Type 1 versus Type 2, and moderate versus high. This slide explains the AA1000 assurance interface. How we go from COC data to disclosure. Sorry, let me check. Okay. There are two engagement types and two assurance levels. Type 1, focus on the process level. It checks whether the organization follows 4 AA1000 principles: inclusivity, materiality, responsiveness, and impact. Type 2 includes Type 1 and also checks the reliability of specific sustainability performance information, so it is more data focused. For recycled material claims, Type 2 is usually more relevant because the claim depends on specific data: PCR percentage, mass balance reconciliation, yield and loss, and the time period and boundary. It is not enough to only review governance design. Then we have two assurance levels: moderate and high. High assurance requires more rigorous evidence and testing, while moderate is more limited but still structured. The key message is the picture on the right. The foundation is recycling operation and the COC system, the management system and the internal controls. And on top, we reach disclosure, quality, and the assurance conclusion. Now let's talk about evidence. Good assurance does not rely on one thing. It needs three parts: documents, data, and control. Documents are the traceability trail: declarations, invoices, permits, and SOPs. They tell us what should happen. Data is the numbers, input, output, yield, and loss factors. The key is that numbers must reconcile. Control makes the whole system reliable: calibration control, segregation checks, sampling, and internal review. The message on the slide is simple. Without control, data becomes stories. If we only have documents, we may have a nice story but weak proof. If we only have numbers, we may have calculations but no traceability. When we have all three, we can test consistency, verification, and reconciliation, and then the claim becomes auditable. Now, let's turn that idea into a practical checklist you can use in real audits and projects. This slide is practical checklist for physical content claims. For recycled content claims, the goal is simple: make claims auditable, trace the material, reconcile the numbers, and prove the controls. On the left is the documentary trail. We need supplier declarations and input specifications, especially the source and whether it is pre or post consumer. We need purchase and sales invoices. This is the baseline for mass balance or blending reconciliation. We also check permits and legal authorization and SOPs or work instructions, so we know the site has clear rules and segregation or bookkeeping. On the right is data integrity and controls. Key data points are input, output, yield, and loss or conversion factors. We also check calibration records for weighing and measuring equipment. Site walkthroughs and sampling help confirm segregation is maintained in practice. And for mass balance, we must check allocation boundaries and product grouping logic. Best practice is the line at the bottom. Keep a simple reconciliation table per set per period. Now we know how to make claims auditable. Let's step back and ask, why do companies push recycled plastic so strongly? A big reason is environmental benefits, especially Scope 3 emissions. This section is about environmental benefits. In many cases, recycled plastic resin can have a lower upstream carbon footprint than virgin plastic. especially when we look at supply chain emissions. Mechanical recycling often brings strong energy and resources efficiency, so the benefit can be significant. In corporate carbon accounting, this benefit usually appears in Scope 3 Category 1 because packaging and materials are purchased goods and services. So when brand buyers so when brand buys resins or packaging with verified recycled content, it can reduce upstream emissions in their inventory, depending on the method and data. A small but important note, the size of the benefit is case-specific. It depends on system boundary, energy mix, yields and losses, and allocation rules. That is why traceability and evidence quality matter. So environmental claims are credible, not just assumptions. So recycled plastic can support upstream reductions, but in practice, most of this sits in Scope 3, and Scope 3 is also the hardest part to quantify. This slide explains why Scope 3 is both the biggest opportunity and the hardest to quantify. Scope 3 is often the largest share of emissions, but it is data heavy and very sensitive to assumptions. Many companies start with Scope 1 and 2 because they control the data, but Scope 3 hotspots can remain identified that links to materiality. Also, reduction in Scope 3 depends on supplier and process-specific factors, energy mix, yield and loss, and that links to impact. A common risk is using generic or outdated secondary emissions factors that can distort results and create credibility issues. This link to integrity and transparency. So the practical direction is at the bottom. Priorities supplier-specific primary data where feasible. We improve primary data coverage through supplier engagement and clear data request. This links to inclusivity and responsiveness. Because Scope 3 is data heavy and assumption sensitive, small mistakes can create big credibility risks. Next, I will show you 3 common issues we often see in recycled plastic accounting and how to fix it. This slide shows 3 common issues in Scope 3 accounting for recycled plastics and practical fixes. First, double counting. What goes wrong is that the recycler, the converter, and the brand may all claim exclusive credit for the same reduction. The fix is to clearly define ownership of the benefit in contracts or disclose that benefits are shared across the value chain. Second, mix the data without clarity. What goes wrong is mixing supplier-specific measured data with industry averages without labeling. Hidden assumptions then distort results and make comparisons meaningless. The fix is simple. Tag the data source, measured supplier-specific or secondary average, and clearly explain the boundary, the year, the key methodology assumptions. Third, mass balance free allocation. What goes wrong is that attributed recycled credits may not match the physical reality of a specific product. If the claim becomes consumer-facing, it can easily be misleading. The fix is to use precise wording, like recycled content attributed via mass balance, and disclose allocation rules and system boundary, at least in B2B documentations. The takeaway, Scope 3 is not just a calculation. It is also governance, clear rules, clear labels, and clear communication. To reduce these risks, double counting, unclear data, and misleading mass balance wording, many companies rely on third-party certification. So now let's look at Now we move into third-party certification. The key message is one goal, multiple standards, because supply chain and the claims are not the same. Why do standards exist? First, they help validate recycled content with independent assurance. Second, they provide traceability and a chain of custody across complex value chains. Third, they support market across and regulatory compliance. What differs across standards? One difference is geography and the use cases. Some are more common in Europe, some in North America, and some are global. Another difference is who is certified: recyclers, converters, or even brand owners. And a third difference is the traceability model: physical traceability, controlled blending, or mass balance. In the next slide, we will compare common schemes and clarify what each one is best. Now let's compare main schemes at a glance. What each one is best for. GRS is best for textile and apparel supply chains. A key feature is that it combines recycled content traceability with social and environmental requirements. And remember, the content rule, it can be used for B2B at lower threshold, but consumer-facing product claims typically need a higher threshold. APR-PCR certification is mainly North America focused and best for buyers and sellers of PCR pellets or flakes. It is a clear focus on post-consumer resin quality and traceability. One key point is the eligibility threshold for recyclers, high PCR input. Recyclass is best for the EU plastic value chain, especially recyclers and converters proving origin and traceability. It aligns well with EN 15343 and ISO 22095 concepts. Outside EU 27+3, there is a stronger governance angle with the CSR module. EN 15343 or OK Recycled is strong when you need a clear technical backbone for traceability and recycled content calculation. It's also relevant in Europe for regulatory needs like the Spanish plastic tax, depending on the scheme and the accreditation context. ISCC Plus is best for complex chemical chains where the segregation is not feasible. It supports several COC options, including mass balance. And the key is strong bookkeeping and very clear claim wording. The takeaway: choose the scheme based on geography, supply chain type, and the claim model you need. We have compared the schemes. Now let's talk about what actually causes non-conformity in real audits and a few quick tips to avoid them. This slide is very practical. In many audits, most non-conformities come from daily operational habits, not technical complexity. First, records and retention. Keep complete documentation like supplier declarations and return records as required. Second, clear material identification. Label everything. Polymer type, batch ID, and certified or non-certified status, and store it in clear, traceable locations. Third, outsource the process. If any step is subcontracted, make sure it is in scope and that material ownership and control are clear. Fourth, internal audit and a stress test. Do it regularly and use it to find weakness, not as a tick box task. Fifth, protect the quality during storage, prevent contamination and degradation, like moisture or UV exposure, to avoid output variation. If you do these five things well, traceability becomes much easier and claims are more defensive. Now, let me close with the key takeaways and what you can do next. To conclude, here is what this framework delivers. First, integrity. Certification plus AA1000 assurance version 3 standard helps turn recycled content claims into assurance-ready disclosures. Second, trust. The 4 AA1000 principles strengthen stakeholder confidence because the claim is clear and better evidenced. Third, leadership. Impact-focused reporting shows real circular economy progress, not only making a marketing message. What should practitioners do now? Build stronger data systems and internal controls. Choose certification schemes that match your capability and stakeholder expectations. And stay forward-looking. Regulation is moving from voluntary to more mandatory requirements. Finally, here is a simple checklist: inclusivity, materiality, responsiveness, impact, and evidence. If you can answer these points clearly, your claims are much more defensible. Okay, thank you. I'm happy to take questions. So anyone maybe have some questions, you can check with me.
Thank you very much, Peter. Thank you for sharing your expertise, and thank you for all the attendees. Thank you for joining this webinar, and we are sharing the recording afterwards. And if you have any questions also about standards, AA1000 series of standards, you are always welcome to contact us at standards@accountability.org. And thank you very much once again, Peter.
Okay, thank you, Peppi. Thank you. Thanks everyone for joining with me. Thanks everyone.
Thank you.
Thank you. Bye bye.